So in this series of mathematics, I want to guide you to standard form. So we are going to look at how you can express a number in standard form. Now, why are we looking at standard form? Remember that sometimes we have to work with maybe very large numbers. For example, if you look at the distance from the Earth to the Moon, the distance is approximately, look at this number that I'm writing here. So I want you to look at the number that I'm actually writing there. Can you see the number? So this is the distance, from the Earth, to the Moon, approximately. That is what we can say. Now, if you look at this one, this is 834,400,000. So this is a very big number. Sometimes you can have a very small number. For example, if I tell you the thickness of one of the pages in my books, or maybe in your book, it may be something that 0.000, maybe we can say 0.213 meters. So if you look at this one, it's a very small number. So instead of maybe writing all the zeros in a number, if there are 23 zeros, you writing all of them, sometimes that would be too tedious and make your work to be very dirty. So there's a way of shortening how to write, a very large number or a very small number with a lot of zeros. It is by using what we call as being standard form, expressing a number in standard form. Sometimes expressing a number in standard form, it is also called scientific notation. So you want to express a number in scientific notation. So instead of writing all the zeros in a very big number or in a very small number, writing all the zeros, it would not actually be a neat way of writing that. So you can eliminate that by using the standard form. Now, what exactly is the standard form? Well, the standard form is simply a way, in other words, when you express a number in the form, if you express a number in the form, let me say A multiplied by 10 raised to the power n. So when we express the number A times 10 raised to the power n, remember they are in multiples of 10. Each time we multiply by 10 raised to the power n. But what does this A there represent? Well, the A there, you need to remember it's a number between 1 and, let me say 1 and 10. Or I can simply say, where we can say that 1 should be less or equal to A and A should be less than 10. In other words, this value that you're going to have here can only be between 1 and 9. When we say less or equal to, we include this sign there, the equal to. It means this value is included. You can see here it's not there, meaning that numbers can only run from 1 up to 9. That is what we mean. Now, what about in this case the n? Well, n is an integer. So n is an integer. That's what we mean. So n is an integer. Now, that value of n will depend on the type of number that you are looking at. It will tell you how many times you have moved, either going to your left or to your right. Let me just show you what I mean, by that. For example, we can start with, numbers, greater than 1. So if you're dealing with numbers that are actually greater than 1, for numbers that are greater than 1, you're going to find that n is always positive. Is always going to be positive. That's what I mean. So if you're dealing with numbers that are actually greater than 1, then the value of n is going to be greater than 1. For example, if you have a number 230,000 and they tell you to express this in standard form, the first thing that you need to know is where is the decimal point, because you cannot see it in this number that they have given you. Well, if you cannot see the decimal number in the number that they have given you, then it simply means that it should be found, at the end. It should be found at the end of a number. So that is where we are going to put it there. I've used the blue marker. So now you are going to move it, going in this case, to the left and stop it between 2 and 3. In other words, the first digit at the beginning and the second digit. That's what we are going to do. So 1, 2, 3, 4, 5. So it is going to be 2.3. Then you are going to say times 10 to the power what? How many times have we moved this decimal point? 1, 2, 3, 4, 5. So it is raised to the power 5. That's what we mean there. Remember, when the number you are dealing with is actually greater than 1, then n is always positive. So that value of n that we have there. So we have expressed this number in standard form or scientific notation as we mean. Hopefully we are together. Let's try to look at another example. Let's try to look at another example so that you are able to see. Suppose 438. Where is the decimal point? Well, the decimal point means it's there. So I'm going to move it between the first digit to my left and the second digit. That's where it needs to stop. So 1, 2. So meaning this can actually be written as, we can write it as 4.38 times 10 raised to the power. How many times have you moved it? 1, 2. So you have actually moved it 2 times. So it will be raised to the power 2. Well, someone might have said, but what about those zeros there? Well, in the meantime, I've just ignored the zeros, but you're going to understand later on when we look at significant significant figures. So that is what we are going to look at. All right. Let's look at another situation. Suppose you are dealing with numbers, less than 1. As long as you're dealing with numbers that are less than 1, n is always negative. So if you're dealing with numbers that are less than 1, your n will always be a negative. What do I mean when I say that? Let's take, for example, you have the number 0.00, then 0.03546. And they tell you to express this one in standard form. Of course, they have already shown us a decimal point there, so we don't need to worry about that. So now you are going to move it. When you have a number less than 1, your decimal point should be moved going to your right. Now you move it such that it stops between as you go to your right, the first digit that you find is a 3 and the second digit is a 5. So you are going to stop it between 3 and 5 as you move it to your right. So let's check how many times we are going to move it. So this is 1, 2, 3, 4, 5, 6. So meaning the point to come there, it will be 3.546 times. Remember, we always multiply in multiples of 10 times 10 to the power what? You have moved, how many times have you moved the decimal point? 1, 2, 3, 4, 5, 6. So it will be raised to the power -6. Remember, I said n is always negative, so that would be -6. That is the solution that you have there. Remember, that is what we can do. Let's look at some more practice questions. Let me just give you some more practice questions so that we can see if you have actually understood how to express a number in standard form or in scientific notation. Let's say, write in standard form. So write in standard form. Let me say number 1, we can have that number there, 20,015. 2, we can have the number 175. Then 3, maybe we can have a number, we can have a number 3,200,000. And let me say 4, you have 0.127. Then let me say 5, 0.00506. So let's look at if that is the number that we are going to have. So I'll call this one as being our first practice question that we are going to have there. All right, so we just want to express these numbers in standard form. So how do we do that? So write in standard form, that one is 20,000, 20,015. If you look at where's the decimal point, identify. If at all you don't see it, identify where it is. And if you haven't seen it, it simply means it's at the end of the number, at the far end there. So where are we going to stop it? Between the first digit to my left and the second one. So we'll move it 1, 2, 3, 4. So that is the way it is going to be. So we'll move it 4 times. So the decimal point will now be there. So meaning we can write it as 2.0015 times 10 raised to the power. Remember, 1, 2, 3, 4. If the number is greater than 1, you raise it to a positive. You're going to raise it to a positive index. So this is what you're going to have. Your n is going to be a positive. That's what we mean. All right. Number 2, I hope you're following. It is simply 175. Where is the decimal number again? Wow, you remember that. That's true. It is at the end there. So we can move it 1, 2. So it will become there. So therefore we can write 175 in standard form as 1.75. Remember to multiply by multiples of 10 times 10 raised to the power 1, 2. So it will be raised to the power 2 because this number is greater than 1. I hope it's making sense for you as we look at it. All right, let's look at number 3 there. Number 3, they have actually given us 3,200,000. Again, if you look at this one, the decimal point is at the far end there. So we'll move it again. We'll move it 1, 2, 3, 4, 5, 6. This is where it is going to be between the first digit and the second digit. So it will be 3.2. I can ignore the zeros because they're at the end. Don't worry, we'll talk about them later on. Multiply by 10 raised to the power. How many times have I moved this guy? I've actually moved it 6 times. So remember, that is going to be a positive. Let's look at number 4. Number 4 says 0.127. All right. So this is a number that is less than 1. So meaning the decimal point will be going to the right. So how many times do you need to move it? What is the first number you are finding as you go in that direction to your right? It's 1. That's the first number. So you stop it between the first and the second one. So we'll just move it once there. So it is going to become 1.27 times 10 raised to the power. Remember, if the number is less than 1, I've moved it 1, so it will be raised to the power -1. So that is what you need to remember there. All right, hopefully we are together. The last but not the least, 0.00506. Again, we have the a decimal number less than 1, so we need to move the decimal point going to the right. But where are we going to stop it? The first number that you are encountering as you go to the right is a 5. So between 5 and 0, that's why you stop your decimal point. So it will be 1, 2, 3 there to stop there. So meaning you ignore these when you're writing in scientific notation. These are no longer going to be there. So it will be 5.06 times 10 raised to the power 1, 2, 3. So it will be -3. So that is what we mean there. So you have expressed in what we are calling as being, standard form. All right, so you may encounter some others. Let me just give you an example. We can also tell you to express the number in a normal way, the way it was given in standard form, and we want you to express in a normal way. So you should be able to know how to express a number in a normal way. So let's call it as being number 2. Maybe I can say that write in the normal way. So that's what they mean. Number 1, maybe you have 9.013 times 10 to the power -3. Then 2, you have 1.0007 times 10 to the power 7. Now I want you to write this in a normal way. They have been written in standard form, but let's write them in a normal way. Of course, you need to remember this because these are gymnastics that you need to know, that you are going to be applying even in other subjects like physics, chemistry, and the like. So as you even advance up there. So we look at the solution to question number 2. In a normal way, I've got 9.01. Let me just write it that's 9.013 times 10 raised to the power negative. Remember, that is raised to -3, meaning the decimal point should be moving to your left now. So you move it how many times to your left? You're going to move the decimal point to your left, but how many times? 3 times. Because of that negative, so it will be 1, 2, 3. So meaning the point will come here. So now right in front here, there should be a 0 there, there should be a 0, and even after the decimal point there should be a 0. So meaning we can write the number as 0.009013. So that is a normal way of actually writing it. That's a normal way, the way it was before they wrote it in standard form or scientific notation as we are calling it. All right. The second one there says 1.0007 times 10 to the power 7. What does that tell you? Well, it simply tells you to say, you know, because that's positive, meaning the decimal point is going to your right, but you need to move it 7 times. So it will be 1, 2, 3, 4, 5, 6, 7. So look at how many zeros we are going to have there. So it will be 10007. We have here a 0, there we have a 0 and another 0 there. So you can see it was here 1, 2, 3, 4, 5, 6, 7. So it has come there, but we'll not show it in this case as we write it. So this is a normal way, you know, the number was before they wrote it in scientific or standard form. Thank you so much for watching. I hope you enjoyed. Please take time to go through so that you can understand the concept. You can rewatch as many times so that you get to grasp the points. Thank you so much.